Hi, everyone, and thank you for attending this webinar. The agenda for this webinar includes going through the basics of machine learning. Kriti and I will then discuss the latest trends that exist in machine learning. For this webinar, we are going to be focusing on the usage of two tools, Snowflake and Databricks. If at any time during this webinar you have any kind of questions, please feel free to leave them in the Q&A box. I'm Bronson, a senior consultant at Altus. A bit of a backstory. After completing my university in India in IT, I never believed I could actually work in IT. So I took up a career in graphic design. I worked in the graphic design industry for close to 6 years. And one of the most interesting projects I worked out there was building infographics. And the reason I liked it was because I could use data to communicate with people. And that's something that set a step for me to grow, like have a career in data. I decided to do a course in IT and I moved to New Zealand in 2016. And I started as a graduate business intelligence dev at AUT, and I continued to grow on from there. Earlier this year, Kriti and I collaborated on working on a machine learning project where we created a unified view for customers by using fuzzy matching.
Hello everyone, I'm Kriti. I'm a senior BI consultant here at Altus. Altus is a data strategy and consulting company which is in market for over 25 years now. Prior to this, I have worked with the product-based companies like PharmIQ and Reagan here in New Zealand. I feel myself fortunate to have seen different flavors of using the same skill as I've worked in academia back in India, product-based companies, and now I'm here in consultancy company. Ever since my bachelor's, I had this inclination towards data and data science field, which led to pursue my career here. I'm astonished to see how far we have traveled in this field of data. The same old data is now being acquired, transformed, and interpreted in so many ways. One of the interesting projects I worked on was exploring the customer journey and predicting the churn based on the user behavior. I think churn retention and repeat customers are the key success to any business. Keeping this in mind, I would like to talk about one such use case in this webinar today. Without further ado, let us dive into the presentation. Did you know that based on the latest surveys, 70% of sales call times were reduced just by using AI and ML? These surveyed companies have also seen that machine learning create 40 to 60% cost reductions and 50% increase in leads and appointments. In addition, these systems also save human salespeople time and energy, allowing them to focus on other side of business and generate even more revenue for the company. Machine learning is most popular technique of predicting the future or classifying the information. With the help of machine learning, we can develop intelligent systems that are capable of taking decisions on an autonomous basis. The algorithms are trained over instances or examples through which they learn from past experiences using statistical analysis and pattern matching. Then, based on the learned data, it provides us with the predicted results. And as it trains over the examples again and again, it improves the prediction about the future.
There are three different types of machine learning: supervised, unsupervised, and reinforcement. In supervised learning, the model is trained based on the given output and is expected based on the given input and its expected output. That is the label of the input. So for example, if we were to create a model that was to differentiate between a cat and a dog, to train this model, we would need to feed multiple images of cats and dogs into the model with a label indicating whether the image is a cat or a dog. The model then tries to develop an equation between the input images and their label. After the training, the model can predict whether the image is of a cat, a dog, or a mouse, even if the image is previously unseen by the model. In unsupervised learning, the model is trained only on the inputs without their labels. The model classifies the input data into classes that have similar features. So for example, if we had two different cups of color red and blue, we would have to classify them into two classes. Let's say all the features of these cups have the same except for their color. The model will try to find dissimilar features between the cups on the basis of how the model can classify the cups into two classes. After the cups are classified into classes depending on the color, we get two different clusters, blue and red. In reinforcement learning, the model tries to take the best possible action in a given situation to maximize the total profit. So if we have subject A that is given a choice to choose between path A and path B, in the beginning, the subject can choose either of the paths because it doesn't have any past experience. The subject is then given feedback on the path it chose, and it learns from its feedback. The next time the subject gets in a similar situation, it can use the previous feedback. So if the subject had earlier chosen path B and some kind of reward was provided to that for choosing path B, the next time it can rethink whether it has to choose A or choose B depending upon the reward it's gaining. A few different machine learning trends we would like to talk about. The first is multimodal ML. In multimodal machine learning, it's a type of machine learning where the model is trained to understand and work with different forms of input data. Let's take image captioning that is used for tagging video content on popular streaming services. The visuals can sometimes be misleading. Even as humans, we might confuse different shapes for different animals or different silhouettes. However, if the same model can perceive sounds, it might become better at resolving such cases. So that is where multimodal ML can be helpful. Multitask model are AI models that are given the object that targets a particular business metric, such as maximizing revenue. Filtering messaging is not a cakewalk. From emails to your messages, it can have crucial information. At the same time, it can be harmful depending on what kind of information is coming through. Multitask models can be used for spam filtration to filter messages and get the best outputs. AI-based cybersecurity has been used for a really long time to deal with cybersecurity threats in real time. Security screening done by immigration officers and customs can help detect people lying about their intentions. The computer stats or ComStats AI system has been used in the police department in New York since 1995. One of the best examples of improved language model is your ChatGPT, which is being widely used in areas for automated customer support, user experiences, and any kind of use case you can think about these days. Embedded machine learning is a subfield of machine learning that enables machine learning technologies to run on different devices. So your instances of OK Google, Alexa, Hey Siri are examples of tiny ML machine learning. It is also used in household appliances, smartphones, laptops, and smart home systems.
Let us now look at some real-time applications of machine learning. These are the applications that I will be discussing have been categorized into the sectors as identified. Starting with the education sector, one of the use case is predicting at-risk students. Not only can machine learning help predict if the student is at risk of dropping out, but they can also determine what factors contributed the most to a student dropping out. An early warning and detection system built using machine learning can assist the schools with identifying and recommending interventions long before the student has actually dropped out. Automation of administrative tasks is another use case where the teachers spend a lot of time grading assessments such as homework, quizzes, tests, etc. Machine learning can be an aid to automate the assessment of these multiple choice and true or false type of responses. In marketing, there's an example for customer journey optimization. Reinforcement machine learning is one of the techniques used to predict the forecast the next touch point to enhance the possibility of a specific outcome. Machine learning algorithms can determine the real-time points of interest for the customer journey to develop realistic and data-driven recommendations. Customer experience is another use case. Better customer experience leads to less churn. Machine learning can assist in enhancement of customer experience in several ways, and communication is one of the keys to achieve the marketing goals and objective. So chat bots and recommender systems can lead to higher customer experiences. In finance sector, most of us, we already know credit card fraud detection, for example, is proven solution to improve the transactional and financial security. Classification algorithms can effectively label the events as fraudulent or suspected to eliminate the chances of fraud. Stock market price prediction is another use case wherein the organizations worldwide are using machine learning techniques and models to conduct sentiment analysis for stock market price prediction. Cybersecurity is the hot topic for machine learning use cases. One of the use cases is email monitoring. Natural language processing is one of the technologies to analyze email content and determine the possibility of phishing attempts. Anomaly detection and using machine learning technologies is also effective in performing email monitoring. Another use case for cybersecurity is ML, again, bots. We know bots are everywhere now. Do you know it contributes to 25% of overall web traffic? Most of these bots are malicious and can cause cybersecurity attacks such as data breaches, malware attacks, or other threats. Machine learning algorithm can be effective in fighting against these bots by identifying them and categorizing them into good and bad bots. Machine learning also has its presence in healthcare industry. One of the use cases being personalized treatment, which allows the healthcare organizations to deliver the personalized patient care by analyzing patients' medical history, symptoms, tests, etc. Detecting diseases in early stage is so helpful. A combination of supervised and unsupervised algorithms under the machine learning provides better assistance to doctors in early detection of diseases. ML compares new data with the old data on a particular disease, and if the symptom shows a red flag, the doctor can take the actions accordingly. In retail sector, recommendation engine is one of the popular use case where many e-commerce giants such as Amazon, eBay, etc. They use Python-based ML recommendation engines for effective interaction between the functions. It leads to the benefits for the e-commerce firms and the customers as they can easily access the products and services according to their choices. Dynamic pricing is another use case where the online retailers use ML algorithms and techniques to determine the dynamic pricing of a product or a service. These techniques make it possible to map the best price for each product. The idea behind the process is to enhance the sales while optimizing the inventory at the same time. In this webinar, I will be considering the use case of predicting the customer churn for a bank. I'll be presenting as to how we can implement this model for the how we can implement the machine learning model for this use case using Snowflake. Why do I talk on customer churn? As per Harvard Business Review and latest article published in Forbes, it costs us 5 times more to acquire a new customer than to retain an existing one. If we are able to predict the churn early, then measures can be taken in retaining them. Here, I intend to analyze if the customer churns. Let us look at the Snowflake and its architecture to begin with. What is Snowflake? Snowflake is an analytical data warehouse which enables data storage, processing, analytical solutions that are faster, easier to use, and more flexible than any other traditional data warehouses. It uses NewSQL database engine with unique architecture designed for cloud. It runs completely on cloud architecture and it cannot be run on premises. So this is the architecture. At the core, we have storage layer. When the data is loaded, Snowflake reorganizes the data into internal, optimized, compressed, and columnar format. The Snowflake stores this optimized data into cloud storage. The data objects stored by Snowflake are not directly visible or accessible by the customers. Instead, they are only accessible through SQL query operations that are run using Snowflake. On top of this layer is a processing layer, which performs query execution. Snowflake processes the queries using virtual warehouses. Each virtual warehouse is an independent, massively parallel processing compute cluster that does not share compute resources with other virtual warehouses. Thus, it has no impact on the performance of other virtual warehouses. On top of this layer is a cloud service layer, which is a collection of services that coordinate activities across Snowflake, like authentication, infrastructure management, metadata management, query passing and optimization, access control, etc. On top of all these layers, there is SnowGrid. What is SnowGrid? It's a cross-cloud technology layer which interconnects business ecosystems across the regions and clouds, thus enabling us to discover and share the data between the teams, allowing for instant access to an up-to-date information. Snowflake also supports machine learning for data science and AI-driven data science applications. Snowflake Snowpark delivers runtime libraries that securely deploy and process non-SQL code in Snowflake using Python, Java, Scala. Automated machine learning is a process of automating the task by applying machine learning to real-world problems. Snowflake also partners with a wide range of machine learning solution providers in the market, including Amazon SageMaker, Dataiku, H2O, DataRobot, Google Cloud, etc. We can use Python UDF, a user-defined function that is defined in a Snowpark library. We can use it for batch inferencing. And if you want to do real-time inferencing, then Amazon SageMaker is a preferred one. So today, I'll be focusing on the usage of Snowpark library for this demo. Before jumping into the demo, let us look at the ML workflow. Snowpark is a machine learning and data science framework that offers the power of SQL within Python flexibility. We can build an application that processes the data in Snowflake without actually having to move to the system where the application code runs. We can use two different approaches to train and deploy the models in Snowflake using Snowpark for Python. So this is the first approach wherein the data is obtained from the Snowflake for pre-processing. After data is pre-processed, we can train the model locally, upload it to the stage, and load it from the stage whenever the Python's user-defined function is called. Alternatively, in the second approach, instead of everything remains the same, instead of training the model locally, what we do here is we just call a stored procedure which performs this task. So whenever a stored procedure is called, it trains the model and saves the trained model into the Snowflake. And again, as like the previous approach, whenever the Python UDF is called, it loads it from stage. The data for this use case is being obtained from Kaggle. The goal is to determine whether a customer will churn. We will see how to build a random forest classifier model, which is supervised learning using Snowpark for Python. I'll stop sharing the slide now and jump onto Jupyter Notebook for demo. So this is a Snowflake IDE wherein I have the databases and I have two tables in this database. So this table, churn modeling, is the data that I have obtained from Kaggle. It was in a CSV format and I have loaded it into the Snowflake database. And this is how it looks. So there are few columns. I'll just quickly go through it. We have row number, which is just a record number. Then there's a customer ID. I don't think that's much importance for our analysis. We have surname, credit score, geography, gender, age, tenure. Tenure is in the terms of number of years that the customer is with the bank. Then balance, number of products, has credit card, is active member, estimated salary, and exited. So exited refers to churn. And these columns, has credit card, is active member, and exited, they are binary. So 0 refers no, and 1 refers to yes. So I've loaded the data into the database table, which is in Dev Kriti Warehouse, a bank schema, database bank schema, and the table name is churn modeling. just to be mindful of time, I wouldn't be executing step by step, but I have already built and executed the code. So I would like to just go over and explain how it is built. So our aim is to predict the customer churn using random forest classifier. And as part of that, first we will have to load the data set. As I showed you, the data is currently available in the Snowflake database. So traditionally, I think most of us might be aware, like whenever we are building a machine learning model using Python, we need to load that data into data frame, or if we are using pandas data frame, and then do some pre-processing steps on that. And then we train them, we split the table into training data set, test data set, we train the model, we evaluate the model. So the same process remains, the process remains the same. I am just adding a new feature of Snowpark so that you can get the data connected to Snowflake, get connected to your data that is available in Snowflake, and you can work on the data that is there in the database. So for that, we have snowpark.session library, which we can use it. And then we'll need to pass on the connection parameters like account, region, username, password, database name, schema name, and all. And then session.builder.configs function will help us to get connected to the database, Snowflake database. So we can see that it has connected to the database here. And so next step is to get this data from Snowflake database into our data frame. So we can fetch the data using session.table function. We can specify the table name, and we can fetch that into the pandas data frame. So here we can see the same data that we saw on the Snowflake database table. As part of exploratory data analysis, we will have to identify what are the categorical columns, what are the numerical columns. Because scikit-learn's random forest implementation does not directly handle categorical features, we will have to convert those categorical features into numerical format as well. So that's one of the other steps. So if there are any missing values, we'll have to identify that and we'll have to remove that. And we can also remove some irrelevant columns like row number and customer ID. So as we see, this table has 3 categorical columns. One is surname, geography, and gender. Rest of all are numerical columns. We can see how the data is distributed in the table. There are about 8,000 records which has exited value as 0, that is not churned, and around 2,000 records have exited value as 1. So if we compare it to with the unique geography, then France and Germany has equal number of churn. And if we compare it using the gender column, there is more records for female churn than male churn. So these are some kind of analysis which we can do, but I wouldn't be digging much deep into it at this stage. So let us look at the histograms for the numerical columns. So the credit score, histogram for the credit score, majority of them falls somewhere between 600 to 700. And for age, it's majority of them are between 25 to, most of them are between 25 to 40 years old. Tenure varies from 1 to 9, which is having the maximum values. There are more records which has 0 balance in our data set. There are more number of single product customers, and many customers have credit card. Yeah. So we will fetch the data. We need the data to be columnar. We need to fetch all this data into our data frame. Sorry for that. So at this stage, once I have removed, you can see that I've removed the columns of row number and customer ID here. And also in this code, you can see that we do not have any missing values. So we can say that our data is clean. So at this stage, there is an option. If you want to, rather than doing these steps of cleaning again and again, either one of the option is you can load this data set onto the Snowflake table and maintain that as a table. So whenever you are building a model, or even if you're building any other model, you can directly use this table, clean data. So that's an optional part. But if you want to do that, then session.writePandas is a function wherein you provide the data frame and you provide the table name to which it has to write, the data frame has to be written. So if this table name does not exist, then it will create a new table. If it exists, then it will just append to the existing rows. As part of data pre-processing, we will have to convert the categorical columns into numerical format. As I said, random forest for this scikit-learn does not handle the categorical features well, because of which we'll have to convert them into numerical format. So this is what I'm using label encoder for that, which is most suited for the supervised learning when it comes to classifying the binary classification problem. And our use case is also binary, whether they have churned or not churned. So the churn here is referred to exited column. So here we can see that it has transformed the surname, geography, and gender to numerical format. Just to and we don't need to do the feature scaling here, because it is a random forest classifier. That means it's built. It consists of multiple decision tree algorithm runs, and it uses tree based or rule based approach, and it does not use calculation. It does not need us to provide the calculate distance. So because of that, scaling does not really affect here. And for the purpose of this demo, I have used the basic values of parameters without any major fine tuning to see how the algorithm performs overall. So it's just to see how we can build a training machine learning model in Python using Snowpark. So at the first stage, we'll go and we'll split the training, we'll split the data into training set and test set. So I have used the ratio of 80-20, and with the random state shuffling of 42. It's just an example that I have used. And so then the next step, once the data is ready, we can see the 10,000. There are 10,000 records in the table. So that has been split into 8,000 records for training and 2,000 records for testing. So to build the model, I have called the function of random forest classifier, which is a library in scikit-learn. I provided the for number of tree, the depth of the forest. So it's 20, depth of each tree. And then we can, the default values for the number of trees in the forest is 100. I have not modified that. And minimum number of samples at the base is 10. And I have trained the model. So once this is done, the next step is evaluation. The training set is used to train the machine learning model, while the test set is used for evaluating the performance. The performance can be measured using metrics like accuracy, precision, recall, and F1 scores. Normally, accuracy is not a metric we use to judge the performance of classification model, because for a few reasons, like as possible imbalances in the data could lead to higher accuracy due to imbalanced predictions in only one class. So, but I've still kept that for the sake of completeness. And we can just measure based on the functions. We can just call the precision score function, recall score function, and we can identify and we can understand how the model has actually performed. So this is for the confusion matrix. We can call the confusion matrix function. This is all about building a model, getting the data from Snowflake, and then training the model and evaluating the model. The interesting part in that is provided by Snowflake is we can define Snowpark UDF, which is called user-defined function. So as I was saying, in one of the first approach that we followed, we get the data from the data lake or Snowflake, and then we train the model and we build the model locally, and then we stage it, and then we define a Python UDF to use the data, to use this model whenever a new data arrives. So that Python UDF is called. So how do we actually register this Python UDF onto Snowflake? So first we'll have to create a stage. It's named as model stage. So this is the syntax that we use for, and we need to import Snowpark function library. And this is a syntax where we'll have to create the UDF and register it. The interesting thing about Python UDF is you don't really need to bother about the installation of the required packages in Snowflake. So if you just mention what are the packages that you have used, Snowflake will install it for you. And this @UDF is a syntax that we use for creating the UDF, defining the UDF. So we provide the name of the function and what is the stage location. So we can define under this sentence, we can define the function, and we can call the model to predict the data. And once this Snowpark Python, once this user-defined function is registered, we can call it in two different ways. Either we can call it using Python code, or we can call it within SQL, using SQL code. So if you want to call it using Python code, then we'll have to use the select function, and inside the select function, we will have to pass UDF. It's the call UDF function, and we'll have to pass what is the name of the user-defined function, and whatever result is returned from this function, it can be saved as a table again into the Snowflake. If you want to call it using SQL statement, then it can also be very well done. We just write select in the select statement, we just call the function directly and pass all the columns that we need. So this concludes the demonstration on building random forest classifier using Snowpark for Python. Thank you. I'll pass this on back to Bronson now.
Thank you, Kriti. Just going to share my screen quickly. From my perspective, I feel machine learning shouldn't be restricted, and anyone across organizations should be able to use predictive analytics to benefit the organization. There are several different use cases which experts or analysts can benefit by using low-code tools to build machine learning solutions. In the next few slides, I'm going to dwell into talking about Databricks AutoML and a low-code tool called as Bamboo Lib to build and train ML models. So Databricks is used to process, store, analyze, model the data sets with solutions from business intelligence to machine learning. We can use a Databricks platform to build and deploy machine learning models and analytics dashboards. The Databricks workspace provides us with options for generating dashboards, visualizations, processing workflows, building machine learning model and tracking, and model serving. Out here is the Databricks architecture for machine learning. And this is what we're going to be focusing on is just the AutoML part of it. AutoML, or automated machine learning, is a fully automated model development solution seeking to redesign machine learning. With the scope of automation, AutoML technologies simplify the ML process from data to model selection. Databricks AutoML helps you to automatically apply machine learning to a data set. So you get your preferred data set, you identify what kind of prediction target you want, while AutoML prepares the data set for model training. It then performs and records a set of trials that creates, tunes, and evaluates the models. After the evaluation, it displays the results and provides a Python notebook with the source code for each of the trial run. So you can share that Python notebook with any of your colleagues or modify the code. MLflow is an open source platform to manage the machine learning lifecycle, including experimentation, deployment, and a central model registry. With MLflow, every single step is tracked. The headache of what algorithm you use or what evaluation method you use is reduced. The MLflow tracking component lets you log and query machine model training sessions. So the Bamboo library. So if I was to tell you that to start a successful Databricks machine learning project, you first need to learn how to get the data into Databricks, be able to do any kind of exploration and data wrangling. But Bamboo Lib is a user interface that allows it's a no-code data analysis and transformations from within a Databricks notebook. It will help you simplify the work and speeds up common data wrangling, exploration, and visualization tasks. So it will provide you with a boilerplate code and make the work more efficient. As a developer, I spend a lot of time using Stack Overflow to get the results. And a year back or so, I came across the web tool to build websites called Webflow. So with that in mind, I want to build a Webflow version of machine learning using Databricks. So I'm going to jump into a demo out here. So this is the Databricks interface. And out here, I have created a notebook. And what I've done is that in the first step, I have installed the Bamboo Lib library and imported it. This is the interface that I get for Bamboo library. I'm going to click on read CSV file. It gives me the option to select which CSV file I want. For this demo, I'm going to be using the house prices from USA for the year from 2008 to 2010. This is a sample data set that has been taken from Kaggle. I select it. It gives me the data frame name and how many rows I want to import. I'm going to click on open CSV file. And this is the data that I get. So as you see out here, the main important things that I want to focus on is the date that's been sold and the sales price. For that, I want to make sure that the data types are correct. So for sales price, the data type has to be an integer, which it is. And the next one I want to check is the date sold is a date time, which it isn't. So to change the date type without writing a piece of code, I just need to click on the column and from here select date time and execute. If we see below out here, this is the code that is getting generated. This code can be copied into a new notebook and reutilized or shared. So if we were to do any kind of different transformation, so for example, if I wanted to rename an existing column, I could select it from here in this drop down and select rename column. And here it gives me the option to rename any kind of column. And I just need to execute. That will create a piece of code. For the next step to get this project ready to be taken into AutoML, I'm going to be writing this to the database. So to that, I'm just going to search for the function write to database table. I'm going to give it a friendly name, AutoML webinar house prices. I think that went a bit too long with the table name and execute. So this wrote to the database, and out here in the code, it has updated again. The code is very well commented, so you can read through what is happening and utilize it. So with this way, you can easily do any kind of transformations or data wrangling inside of Databricks. The next step we're going to go is to go into the experiments. And here I'm going to start a new AutoML experiment. The cluster is currently running for machine learning. In the problem types, there is 3 different types: classification, regression, and forecasting. As with this project, we want to see the house prices as it grows in the next maybe years or days. So I'm going to be selecting forecasting. The input training data set is the one we created, which is this one, AutoML webinar house prices. The prediction target is going to be based on the sale price, and the time column is on the dates sold. I'm going to leave all this as is. The horizon and the frequency is going to be 10 days from the last date sold. And this is the experiment name. Out here, you can see the different columns that are available and the data types. And then I'm going to click on Start AutoML. So what's going to happen here is it's going to train your model and then give you different notebooks which you can reutilize. It's going to take approximately 30 minutes, and to speed this up, I had run this earlier this day. So just going to go into one of the older ones. So out here, it does different runs on different types of training models. So it's done on Arima, it is done on Profit, and it will provide you with the best model it feels appropriate for that project. So out here, they've given us 2 different notebooks. We're going to explore the data exploration for notebook first. This code has been generated by Databricks, and it is ready to be utilized or shared. So this is the whole process what they've done, where they have taken the data, done any kind of time column analysis on it, and as well as given you a visualization just showing like how the data has changed over the years. And this is the first step of training the data. Then the next one is where they have utilized that notebook into doing the training. So they've loaded the data, trained the model, and in the final cell, we can get the predicted results. So as you see, they have given 10 days that we had asked for. So this is when I say, let's make it simpler. This is the code that we can reutilize whenever we want, and we can keep on building from here. So this at least helps us to spend lesser time writing the code and more on trying to find better use cases and how we can use machine learning to improve any kind of activities around our organization. Just going to stop sharing with this. So as we are at the end of the webinar, I would like to thank you for attending this. And as a thank you for those who have registered, we are offering a half-day free machine learning readiness assessment. Please sign up by the end of August to receive this. And thank you again for listening to Preeti and me. We are happy to take any kind of questions you have now. Just feel free to leave it in the chat.
For my side of demo, I would like to share the artifact of the code that I have built, which will be sent in the follow-up email for the recording of the webinar.
So I don't see any questions that we received, but please feel free to message us or email us if you want to have any kind of further, if you want to ask anything about this webinar. Also, this webinar is going to be available online. And I think so, Samantha will be sharing with all the registered participants. So thank you so much for attending the webinar today. and have a lovely day.
Thank you. Bye.